this video is about investigation 4 in your book. And the subject of investigation 4 is using inductive and deductive reasoning. So we have two basic types of reasoning. We have inductive and then we have deductive. Now the difference between the two is that inductive bases a conclusion on an observed pattern, whereas deductive bases the conclusion on laws or written rules. For example, if you observe a pattern and you know that the next number, so your pattern is 2, 4, 6, 8, and you can say, okay, I think the next number is going to be 10. That's based on that pattern that you've looked at before. Now, deductive reasoning involves laws. So if you see that two sides of a triangle are 3 and 4, then you know the hypotenuse will be 5 because of the Pythagorean theorem, which is a law or a written rule. So the difference between inductive and deductive is really what do you use to come to your conclusion. Do you use a pattern or do you use a law or rule? Now both can be used to support or justify conclusions. So there are a few words we need to talk about. The first is the premise. A premise is the foundation for an argument and it's used as evidence for the conclusion. So the premise is what are you using to back up your conclusion. The conclusion is an opinion or decision that logically follows the premise. For example, these two statements right here form an argument. All fruits have seeds. An apple is a fruit. Now the premise is all fruits have seeds. That is what you are using as evidence to make your conclusion, which is an apple is a fruit. Because we know that an apple has seeds, and according to the premise, all fruit have seeds, so the apple must be a fruit. Now in inductive reasoning, if the argument or the premise is solid, then the conclusion is supported, but it's not guaranteed because it's based on a pattern. So there can be examples that fall outside of the realm of that conclusion. But if the argument is solid, it's supported. Now in deductive reasoning, if the argument is solid, the conclusion is guaranteed because it's based on a law or a written rule that is always true. So basically, inductive reasoning could have a counterexample, but in deductive reasoning, you're not ever going to have a counterexample. Alright, so let's look at some examples of this. Okay, so this is Daryl, and according to Newton's first law, every object will remain in uniform motion in a straight line unless compelled to change its state by the action of an external force. So, if I kick a ball, it will travel forward at a constant speed until it hits the wall. Now we need to know, first of all, is Daryl's reasoning inductive or deductive? Now let's go back up to the inductive and deductive. Inductive is based on a pattern. Deductive is based on written laws or rules. Now Daryl's conclusion is that if he kicks the ball, it will travel forward at a constant speed until it hits the wall. And since he's basing that on Newton's first law of motion, he's basing it on a law or written rule. So that is deductive reasoning. Now, how do we know? We know that because Daryl's conclusion is based on Newton's first law, which is a written rule. And that written rule is always correct. So because he's basing it on a law or a written rule, we know that this is deductive reasoning. Alright, our next example here deals with Aaliyah. This is Aaliyah. She has an unfortunate mullet. It says, in the past, I've noticed that every time I kick a soccer ball, it travels forward at a constant speed until it hits the wall. The next time I kick a ball, it will keep going until it hits the wall. We need to know, is Aaliyah's reasoning inductive or deductive? Well, her reasoning is that the next time she kicks a ball, it will keep going until it hits the wall. She's basing this on the premise that in the past, she's noticed that every time she kicks the soccer ball, it travels forward at a constant speed until it hits the wall. So since she's basing her conclusion on a past pattern that's been observed, her reasoning is inductive. And again, we know because she is basing her conclusion on her past experience. Now, she's noticed a pattern in the past, and because of that pattern, she's making a conclusion that something will happen in the future. So here we have some other examples. We want to identify the type of reasoning used, and we also need to explain our answer. Now, I'm going to do number 1, but you guys are going to have to fill in numbers 2 and 3 on your own. And number 1, our premise is that a student has earned a score of 100 on the last 5 math tests, and our conclusion is that the student will earn a score of 100 on the next math test. We need to know, is that inductive or deductive reasoning? Since we're basing our conclusion on a premise that has been a past pattern, but there's no written rule for it, this is inductive reasoning. And that is because it is based on a pattern, not a written law or rule. Okay, so you guys are going to need to fill in number 2 and number 3 on your own. Okay, so when we have a premise and a conclusion, it can be written as one sentence. For example, if the measures of 3 angles of a rectangle are all 90 degrees, then the measure of the 4th angle is 90 degrees. Now, this kind of if-then statement is a logical statement called a conditional statement. Now, it's conditional because it tells the conditions under which something happens. And it's made up of 2 parts, the hypothesis and the conclusion. Now, the if part is the hypothesis. That's also what we called the premise previously. And the conclusion follows the then. So we have if, and then the hypothesis, and then, and then the conclusion. Now, a conditional statement can be true or false. Just because somebody says if then doesn't mean that it's necessarily true. Now let's do some examples. It says, use the given hypothesis to write a true or false conditional statement. So we want to write a true conditional statement here. If you stay in the sun too long, now we need a conclusion, so we have to write then, and then we know that what happens if you stay in the sun too long is that you will get a sunburn. Now, I know not everybody sunburns just for staying in the sun for a long time, but if you stay in the sun long enough, eventually you're going to get a sunburn. So this is a true statement. If you stay in the sun too long, then you will get a sunburn. Okay. Number 5, we want to write a true conditional statement. If a student has a temperature higher than 101 degrees, now that's our premise or our hypothesis. Our conclusion needs to start with then, and then we need to write something true that is a result of that. So now there's not necessarily a set rule for something that you do if you have a temperature of higher than 101 degrees, but there are things that you should do. So we could say if a student has a temperature higher than 101 degrees, then the student should stay home from school. Should. Notice the should here. That is a true statement. If you have a fever higher than 101 degrees, you really should stay home from school. So we've written a true conditional statement here. And finally, for number 6, we want to write a false conditional statement. Excuse me. So whatever our conclusion is, it needs to not work with the premise or the hypothesis. So our hypothesis is if a number is divisible by 5, and we need a conclusion that starts with then. Now, if a number is divisible by 5, I know that it's going to be a composite number, right? It's going to be divisible by something other than itself and 1. So something false that I could say is, then it is a prime number. Now, the only prime number that's divisible by 5 is going to be 5. So this is a false conditional statement. Just because a number is divisible by 5 does not mean that it is a prime number. Now, here we have a discussion of counterexamples, and we already know that counterexamples are examples that contradict a statement, and that it only takes one counterexample to show that the statement is false. For example, our hypothesis, if a figure has 4 sides, then it is a square, is our conclusion. Now, we know this is a false statement because we can provide a counterexample. A rectangle has 4 sides, but it's not a square. So for number 7, I'm going to do number 7. You will have to fill in number 8 on your worksheet on your own. So number 7, we want to provide a counterexample for this statement. The sum of a positive number and a negative number is negative. Now we know that's not true because if you add a positive number that has a large absolute value and a negative number that has a smaller absolute value, you're going to get a positive number. So this is false, and our counterexample could be something like positive 5 plus negative 3 equals a positive 2. Now that proves that that statement is false. Alright, so number 8, and then the investigation practice on the rest of your paper is all yours.